Morning children. Now today we discuss with the aneroid barometer. Now so far the two types of barometer I have discussed it. Simple barometer and the 14th barometer. Okay, and related with this, please you study yourself. These are very easy to understand. What is the demerits of simple barometer? The disadvantage of simple barometer, and disadvantage of using water as a barometric liquid. Okay, these things you will study. It's given in the book. That is page number 98. Please follow that. It is easy to understand. And another one is also there. That is advantage of using mercury as a barometric liquid. So three things. You please refer your book. That is page number 97 and 98. These three things you study yourself. Okay. Now let us come to the aneroid barometer. Now this aneroid barometer, it does not have any liquid. That means it does not contain any liquid. Whereas in a simple barometer and the 14th barometer, mercury is used as a barometric liquid. But here there is no liquid, any liquid. Okay. And this is very light. This barometer is light. This is portable, small, and easy to carry from one place to another. It is calibrated. Now this is barometer. This aneroid barometer is calibrated, and the atmospheric pressure you can directly find in terms of barometric height. You can directly find the atmospheric pressure since this barometer is calibrated or the graduated mark is given here. That is in a circular scale. Okay, so it does not have any liquid, and it does not require any adjustment like a 14th barometer. 14th barometer, you have to do some adjustment before the atmospheric pressure, before you find the atmospheric pressure. You have to bring the mercury level at a 0 mark, then slowly the mercury level will increase, okay, and you have to measure in the main scale, Werner scale. So all this kind of adjustment is needed in a 14th barometer. But here it's very simple, okay, it's simply these are constructed, and there is no any liquid, there is no any adjustment needed like a 14th barometer. So these are the advantages of aneroid barometer. Now this aneroid barometer, now follow this diagram here. This aneroid barometer consists of metallic box B. It consists of metallic box B. Okay, and on the top of the box, that is D, on the top of the box D, it is in the form of a diaphragm. Okay, it consists of metallic box B, and the top of the box is in the form of a diaphragm. Diaphragm means this part, okay, the upper part of your body, okay, just from your ribs and from this region, the upper part, from the chest region, okay. So when we consider human body, so that is a diaphragm. So the upper part, D is the diaphragm of this box, B is the entire box, D is the diaphragm, okay, it is in the form of a diaphragm, the upper part, and on the diaphragm, a very thin rod L is there, which is toothed at the top region or the top end. There is a thin rod L which falls or which lies on the diaphragm D on the topmost part of the box, and in this rod there is the toothed region, okay, toothed end at the topmost region, and at this toothed region, on this toothed end, the wheel S will fit towards the teeth of this rod L. Okay, which is fitted with this wheel is again fitted with a pointer, okay, and this pointer will move around a circular scale. It will move around the circular scale, and you can find the atmospheric pressure directly, okay, without any adjustment in terms of barometric height. So this way you can find the atmospheric pressure. Now how it works? Okay, now these are very simple. When you see the diagram, these are very simple, and this box is partially evacuated. Okay, the air has been removed. Partially the air has been removed. So this box, okay, metallic box, which is B, and it is partially evacuated. Evacuated means the air has been partially removed. Okay, and the topmost region of this box is in the form of a diaphragm. On the diaphragm B, there is a thin rod L, which is toothed, and through this tooth, the wheel S will feed to the teeth here, okay, and this the wheel of this the wheel S will feed towards the tooth of this rod, and on the wheel there is a pointer, and this pointer will move around a circular scale. And you can find the atmospheric pressure in terms of barometric height. Now the working, how it happens, now how it works. Now when the atmospheric pressure increases, okay, atmospheric pressure can increase or decrease depending upon the temperature, depending upon the altitude, okay, and as well as the density. So when the atmospheric pressure increases, that means it presses the diaphragm D, that means this diaphragm get compressed, that means it presses, okay, and therefore when the atmospheric pressure increases, the diaphragm D will presses, and at the same time this rod L will get depressed. That means this rod will go down. It get depressed. That means when the atmospheric pressure increases, the diaphragm D presses, okay, and the rod L will get depressed. They will go down. Okay, and therefore what will happen when it goes down? This pointer will move towards the right. It will move towards the right. That means in a clockwise direction the pointer will move. Okay, and when the pointer will move towards the clockwise direction, in a circular scale, it is already, the calibration is already given there, graduated mark is already given there. Okay, and when the pointer will move, that pointer will give the atmospheric pressure at a given height. Okay, so this happens when the atmospheric pressure increases. The second point is there, when the atmospheric pressure decreases, okay, when the atmospheric pressure decreases, then again what will happen? This diaphragm, it bulges out. Before that it compressed, okay, it pressed, now it bulges out, that means it comes out. This diaphragm D will bulges out, it comes out, and this rod L, it moves out. And when it moves out, this pointer will again move towards the left, that is anti-clockwise direction. Okay, and when it moves towards the left, then again what will happen? The atmospheric pressure, you can find it. So therefore, this atmospheric pressure, with the help of another barometer, you will find it depending upon the movement of this pointer in a circular scale. Okay, so this way you will find you can read the atmospheric pressure. Okay, and now the uses of barometer. Now this is how the annual barometer works. Uses of barometer, three uses are there. Number one use is it is used to measure the atmospheric pressure of a place. It is used to measure the atmospheric pressure of a place at a place. Second one is for weather forecasting. This barometer is also used to find the weather forecasting, whether there is the weather is worse, whether the cyclone is there, the rainfall is there, okay, if the weather is present. So all this weather forecast is done with the help of the barometer. And the third one is altimeter, that is to find the height. Okay, so these are used, altimeter are used in the aeroplane to find the height. So the for three uses, these barometer are used. Now the next point will come to the variation of atmospheric pressure with altitude. Variation of change in the atmospheric pressure with altitude. Now as you know, when you increase the height, when you go to the higher altitude, the atmospheric pressure it decreases. Now why the atmospheric pressure decreases is that because at a high altitude the air column is less. That means the air becomes thinner and thinner when we go to the higher altitude. Now when we consider this atmosphere consists of layers of air which are parallel to each other. This atmosphere consists of a layer of airs, and this layer of airs are parallel to each other. Okay, these are parallel to each other. Okay, and now this air, when we go the air which are very closer to the Earth's surface, the air which are very closer to the Earth's surface, the air is very thicker. Okay, and when we go to the higher altitude, the air becomes thinner. So when the air becomes thinner at a higher altitude, then what will happen? The atmospheric pressure decreases. Atmospheric pressure will become less. So as the atmospheric pressure will become less, so therefore when the people they go to the higher altitude at a hill station or when they climb towards the mountain, okay, they will have a nose bleeding and they will suffer from a breathing problem. Now why it happens is that because at a higher altitude the atmospheric pressure is less and their blood pressure will become axis. That means the inner pressure will become more. So inner pressure will exit the atmospheric pressure, and therefore the person will have a nose bleeding. So therefore it is advised, right, to the person, the patient, those who are having the high blood pressure, okay, they are not advised to go to the high altitude or at the hill stations, because they may have a nose bleeding, and therefore it may have a fatal effect towards their body. Okay, so this is the point. The next one is also there, that is the density. Okay, now the density, since we know that density is defined as mass per unit volume. Density is defined as mass per unit volume. So that means now at the lower surface, that means the air near the Earth's surface, the density is more. And when we go to the higher altitude, the density will decreases. And when there is a decrease in the density, that leads to the decrease in the atmospheric pressure. Okay, so atmospheric pressure, it decreases to the high altitude. Okay, because there is less air in the high altitude, and as well as the density will also decrease when we go to the higher altitude. And the next point is here, that is other point is at a higher altitude, that the fountain pen it leaks. At a higher altitude, fountain pen it leaks. So how does the leaking of the fountain pen takes place at a higher altitude? Normally now this fountain pen is filled with ink. It is filled with ink and contains some air. That fountain pen is filled with the ink and it contains some air. Okay, and therefore when we in the higher altitude, what will happen? The atmospheric pressure, the outside pressure is less. Outside pressure is less, that is atmospheric pressure is less, and already the air is present inside the fountain pen, and the inside pressure will become more than the outside pressure, and therefore what will happen? The ink will come out through the fountain pen. So therefore the leaking of ink will take place in the fountain even in a higher altitude, same as that of the nose bleeding, which it takes place. Okay. Then other one is the weather forecast. Now how we can know that the weather is present, the weather is there will be the rainfall, there will be the cyclone. So all these things, okay, we can able to know depending upon the atmospheric pressure. Depending upon the atmospheric pressure. Now the first one is if the barometric height, okay, in the barometric height will suddenly falls. If the height of the barometer or the mercury level suddenly it falls, then the pressure at that place suddenly decrease. When the barometric height is suddenly falls, then the pressure at that place it suddenly decreases. The pressure it decreases. That is the atmospheric pressure decreases. And when the atmospheric pressure decreases, then it shows that it indicates there is a storm or a cyclone. Okay, so storm or a cyclone. How to indicate? How it can be indicated is that when the barometric height suddenly it falls, there is a decrease in the pressure, and it indicates that there is a cyclone or the storm. Next point is there again. If the barometric height it gradually increase, slowly it will increase, not at once. When the barometric height will increase gradually, this means that the moisture in the air is decreasing. The moisture present in the air is decreasing. In the air there is a presence of water vapor, there is a presence of moisture. So when the barometric height will gradually fall, barometric height gradually falls, then what will happen is that it states that there is a possibility of the rain. Okay, so possibility of how the rainfall it takes place that when the barometric height they will fall gradually. Okay, gradually the barometric height falls, then the moisture at a place will start increasing. The moisture will increase. Okay, and which means that there is a chance of rainfall. Second one is the gradual increase in the barometric height. When there is a gradual increase in the barometric height, okay, when the barometric height gradually it increases, then the moisture is decreasing. The moisture which are present in the air decreases, and therefore the weather is considered as a dry weather. Okay, so this way you can find it. And the last one is here, if there is sudden rise in the barometric height, sudden rise, not gradual, but if there is sudden rise in the barometric height, then what will happen is that this indicates that the extremely the weather is completely dry. Extremely means a complete dry weather will be there. And the last one, if there is no change in the barometric height, if there is no change in the barometric height, then this indicates that atmospheric pressure is normal. There is a normal atmospheric pressure if there is no any change in the barometric height, therefore the weather remains unchanged. So this way you can find whether there is a rainfall, there is a cyclone, whether the weather is dry weather or extreme dry weather, depending upon the rise or fall of the barometric height. So this way the barometer is used for the three purposes, and the last one is the altimeter. Now altimeter, these are the instrument to measure the height. Okay, these are used in the aircraft to measure its altitude, to measure the height, to measure the altitude. These are the instrument these are used in the aircraft to measure the altitude or the height of the aircraft. So this barometer are used for the three purposes. One is for it is used in the altimeter, that is in the aircraft. These are used to in the weather forecast, and other one is the third one. It can be used to measure the atmospheric pressure at a place. So we have come to the end of this chapter. In the next class, we'll start with another chapter, that is buoyancy.